Welcome back. In the previous lecture, we demonstrated how to solve a system of linear equation by Gaussian elimination. We gave the algorithm or the steps we need to follow and also did some examples. In this lecture, we give more examples on how to solve system of linear equations by Gaussian elimination method. So here is the first appetizer. Solve the system x2 minus x3 equals to 0, x1 minus 3x3 equals to -1, minus x1 plus 3x2 equals to 1. The first step you must always do is to write each equation with the variables involved in the system, and equations which do not have some variables, you force them there by multiplying by coefficient 0. So for example, this having 3 variables, x1, x2, and x3, the first equation will be written as 0x1 plus x2 minus x3. The second will be written as x1 plus 0x2. And the third one will be negative x1 plus 3x2 plus 0x3. And you write the variables to be in line so that when you write the augmented matrix, everything takes the correct position. So then now the augmented matrix will be 0, 1, minus 1. Then you separate by this line 0, 1, 0, minus 3, minus 1. Then -1, 3, 0, 1. This is what we call the augmented matrix. This is what we call the augmented matrix. Now, we need to convert this matrix into row echelon form. And row echelon form, when you have a system with 3 equations, should be this structure. Now, since this is not 1, then we can always interchange row 1 and row 2. So we can say 0, 1, minus 1, 0, 1, 0, minus 3, minus 1, minus 1, 3, 0, 1. Row 1 will be row 2, and row 2 will be row 1, and then row 3 to remain to be row 3. So by doing that, we'll have 1, 0, minus 3, minus 1, 0, 1, minus 1, 0, minus 1, 3, 0, 1. So by doing that interchange of 2 rows, we get the correct element in this position. Now the problem with this first column is -1. So we'll correct this -1 by this one in the first row. So let's say row 1 to be row 1, row 2 to be row 2, and then row 3 to be row 3 plus 1 times row 1. So that I get 0 in this position of -1. So this will lead me to 1, 0, minus 3, minus 1, 0, 1, minus 1, 0. -1 plus 1 is 0. 3 plus 0 is 3. 0 plus -3 is -3. 1 plus -1 is 0. So by doing that, first column is in the correct form. So this is 1, this also 1. So which means the problem is these 3. So we'll say row 1 to be row 1, row 2 to be row 2, and then row 3 to be row 3 plus -3 times row 2. So when I multiply this 1 by -3, I add to this 3, I am sure that I'll get 0 at this position. So 1, 0, minus 3, minus 1, 0, 1, minus 1, 0, 0, 0, minus 3 plus minus 3 times minus 1 should be minus 3 plus 3, so which will be 0, and this is 0. So we find out that the last row is purely having zeros. So this is 1, this is 1, but everything here is 0. So this matrix in the row is in the row echelon form. So writing in the original system, where the variables in the system were x1, x2, x3, so we'll have x1 minus 3x3 equals to negative 1. And from row 2, x2 minus x3 equals to 0. So here, x3 is a free variable. So let x3 to be say t, where t is any real number. So from 2, x2 is x3, which will be t. So therefore, the value of x2 is the same as x3, is the same as t. And from 1, if 1, and this is 2, from 1, x1 is minus 1 plus 3 x3, which means x1 will be 3t minus 1 because x3 is taken to be t. So therefore, the solution is x1 equals to 3t minus 1, x2 is t, and x3 is t, where t is a real parameter. So this is a system which has infinitely many solutions depending on the values of the parameter t. Example 2. Solve the system x2 plus x3 minus 2x4 equals to minus 3, x1 plus 2x2 minus x3 equals to 2. Next equation is 2x1 plus 4x2 plus x3 minus 3x4 equals to minus 2. And lastly, x1 minus 4x2 minus 7x3 minus x4 is given by minus 19. As I've said earlier, you ensure that each equation has all the variables which are being considered. So here we have 4 variables. So we can write this first equation as 0x1 plus x2 plus x3 minus 2x4. And this other one will be written as you add here x4. So that now it becomes easy to write the matrix, the system into augmented form. So the augmented form will be 0, 1, 1, minus 2, minus 3, 1, 2, minus 1, 0, 2, 2, 4, 1, minus 3, minus 2, 1, minus 4, minus 7, minus 1, minus 19. So this is what we call the augmented matrix of the system. So next, we now reduce the augmented matrix into row echelon form. So we have 0, 1, 1 minus 2, minus 3, 1, 2, minus 1, 0, 2, 2, 4, 1, minus 3, minus 2, 1, minus 4, minus 7, minus 1, minus 19. So we want now to do the process of converting into echelon form. Echelon form, this being a system of 4 equations, we expect to have 1, 0, 1, 0, 0, 1, 0, 0, 0, 1, something like this. So this is not 0, this is not 1. So we expect this to be 1. So we can actually achieve that one by interchanging row 1 and row 2. So we say, let row 1 be the same as row 2, and let row 2 be the same as row 1. And then let's keep row 3, and let's keep row 4. So by doing that, we get 1, 2, minus 1, 0, 2, 0, 1, 1, minus 2, minus 3, 2, 4, 1, minus 3, minus 2, 1, minus 4, minus 7, minus 1, minus 19. Next. So row 1 is now in the correct position, the correct structure. So row 1 is row 1. Row 2 is also in the correct form at this step because this is 0. So let's say row 2 to be row 2. Row 3, we expect this to be 0, and we do that correction by row 1. So we'll say row 3 plus minus 2 times row 1, so that I'm sure of getting 0 here. Row 3, or row 4, will be row 4 plus negative 1 times row 1. That will assure me having a 0 here. So that will lead me to 1, 2, minus 1, 0, 2, 0, 1, 1, minus 2, minus 3. So there is 0, 4, minus, I'll have 4 plus minus 2 times minus 2 times positive 2 would be 4 minus 4, which is 0. So I'll have 0 here. And then 1 plus minus 2 times minus 1. So 1 plus 2 is 3. So I'll have here 3. And then minus 3 plus minus 2 times 0 is just minus 3. And then minus 2 plus minus 2 times 2 is minus 2 minus 4, which is minus 6. So I'll have minus 6 here. Remember this minus 3. So 1 minus 1 is 0, minus 4 minus 2 is minus 6, minus 7 plus minus 1 times minus 1, so minus 7 plus 1 is minus 6, minus 1 plus minus 1 times 0 is minus 1, and then minus 19 plus minus 1 times 2 is minus 19 minus 2, which is minus 21. So I get here minus 21. So we see that at this step, this is correct, this is correct. So this we expect here to have a 0. So we'll say row 1 to be row 1, row 2 to be row 2. All these are also 0. Let's keep row 3 to be row 3, and row 4 to be now row 4. We correct by row 2 plus 6, row 2. So which will be, that leads to 1, 2, minus 1, 0, 2, 0, 1, 1 minus 2 minus 3, 0, 0, 3 minus 3 minus 6, 0. So it'll be 0. Minus 6 plus 6 times 1 is 0. Minus 1 plus 6 times minus 2. So minus 1 minus 12. I get minus 13. Then minus 21 plus 6 times minus 3. So it'll be minus 21 minus 18. So 21, 18 is 39. So minus 39. Now we expect to have a 1 here and also a 1 here. So I can say row 1 to be row 1, row 2 to be row 2, row 3, I can correct it by multiplying a third by row 3, and row 4, I can correct by multiplying by negative 1 over 13 row 4. So that will lead me into 1, 2, minus 1, 0, 2, 0, 1, 1, minus 2, minus 3, 0, 0, 1, minus 1, minus 2, 0, 0, 0, 1, 3. And now, clearly this matrix is in the row echelon form because you say this is 1, this is 1, this is 1, this is also 1. So row echelon form. So then now rewrite the original system using this row echelon form matrix. So we get x1 plus 2x2 minus x3 equals to 2. And then x2 plus x3 minus 2x4 equals to minus 3. And x3 minus x4 equals to negative 2. And lastly, x3, x4 is 3. So we call this equation 1, equation 2, equation 3, and then equation 4. So clearly from 4, x4 is 3. So from equation 3, we get x3 is minus 2 plus x4, which should be minus 2 plus 3, which is 1. So x3 is 1. And from equation 2, we have x2 equals to minus 3 plus 2x4 minus x3. So which will be minus 3 plus 2 times 3 minus 1, which is minus 3 plus 6 minus 1. And this will give us minus 3 plus 6 is positive 3 minus 1 is 2. And we can get now the x1. X1 from here, we have x1 equals to 2 plus x3 minus 2x2, which will be 2 plus x3 from our computation is 1, minus 2 times x2 from our computation is 2. So which will be 2 plus 1 minus 4, which will be minus 1. So therefore, x1 is minus 1. Hence, the solution to the system is x1 is minus 1, x2 is 2, x3 is 1, and x4 is 3. That's how we solve that given question. Now, the next session will do an example involving how to use Gaussian elimination method to give conditions to some parameters in a given system of linear equations that guarantees either a unique solution or many solutions to the system. Thank you.